dbt core has been the standard for data transformation for years, and it has done a good job at this. But there's one limitation. dbt core is built on Python, and it has no idea what your SQL actually means until it reaches the data warehouse and an error is returned. Now, dbt Fusion Engine changes that completely. And in this video, I'm going to break down exactly what dbt Fusion is, how it works, and why every data engineer and analytics engineer needs to understand it. Welcome back to David Data Channel. I'm David, and on this channel, we cover practical AI, data, product, and analytics engineering contents without the hype. This is episode 1 of my dbt Fusion Engine series, and in the next couple of videos, we'll be covering everything from conceptual foundations to hands-on demos and deployment features of dbt Fusion. In today's video, we'll cover what dbt Fusion Engine actually is. We'll cover the key differences between how dbt Core and dbt Fusion processes your project, and also what this means practically for your development workflows, your deployment workflows, and also your data warehouse compute costs. Alright, before I talk about Fusion, let's be honest about how dbt Core works today, because an understanding of how dbt Core works today would give us an understanding of the limitations and make the solution make more sense. Today, when you run dbt Core takes your Ginger templated SQL, renders it into plain SQL, and sends it to your data warehouse and moves on to the next model. Essentially, it helps you convert your ref functions, your source functions, and calls the actual table names and hands that query off to Snowflake, BigQuery, or whatever data warehouse you're using right before it executes. Now, dbt Core understands your DAG, your Ginger templated SQL, but does not have a deep understanding of your SQL structure. So if, for example, if model B in your DAG has a broken join, or a column name that doesn't exist, or a syntax error, for example, dbt Core won't catch it until it tries to run that model B, and then by then model A would have run already. You've waited for it to run, and you've also expanded data warehouse compute. For a long time, this has been good enough, but as projects become bigger, as DAGs become longer and complicated, this approach actually now has real cost impacts. So imagine the syntax error was on model 15 down the line. You would see how that would be impactful in your cost. So what exactly is Fusion? Now, according to dbt docs, Fusion is an entirely new piece of software. It's not an update or upgrade to dbt Core. It's a completely new engine written in Rust and not Python. As a matter of fact, dbt Fusion went GA as at 1st of May 2026, and is currently available within Snowflake, right, and beta and other adapters. And the goal of Fusion is to support the full dbt Core framework and capabilities, plus a superset of other functions and capabilities that dbt Core never had. What are the 3 big things to know right now? First of all, it is significantly faster. dbt Labs reports passing speed 30 times faster than dbt Core. Also, dbt Fusion has native understanding of SQL across multiple warehouse dialects. And thirdly, is that dbt Fusion is available in 3 ways today, through the Fusion CLI, the dbt VS Code, Core VS Code extension, and also dbt Cloud Platform. The CLI and the VS Code extensions are free, but for some features like the state-aware orchestration, you require the dbt, a paid dbt platform plan to actually use that feature. And this is actually what separates Fusion from dbt Core at a very technical level, because Fusion introduces static analysis. What is static analysis and how does it work? Now, when you run Fusion, it doesn't just render your models and fires them at your data warehouse. It renders all your models first across your entire DAG, and then runs static analysis to produce and validate a logical plan for every single query that will be run against the data warehouse. And once everything passes, Fusion now begins executing against your data warehouse. This is called ahead of time rendering, or AOT. And dbt Core, by contrast, works by just in time, or JIT rendering, which means it renders one model and then runs it and moves on to the next, whereas dbt Fusion does ahead of time rendering. dbt Core primarily validates your models during execution flow, whereas Fusion performs much more deeper project-wide SQL analysis before execution. Think about what ahead of time means for you. If model 15 in your DAG has a broken column or a wrong syntax, for example, Fusion catches it before any model runs. This way you don't have to spend compute credit before reaching your point of failure, or waiting for the model to run up to that point or the job to run to that point before it fails. So essentially, Fusion now turns DBT from just a templating and execution framework into something much more powerful, something that understands your SQL natively, and now a true SQL compiler. Also, Fusion uses the same understanding of your SQL to power features like your inline error highlighting as you type it in your editor using the VS Code, the DBT Fusion VS Code extension. You can also experience live CT previews where you can see an output of a CT without running the full model, and also column level lineage that allows you to trace how columns, the lineages between columns from upstream downstream, without having to go through several YAML files. Right, this is currently available within DBT Fusion, and you can actually see this with your VS Code extension. Now, this is powered by Fusion's understanding of your SQL at a structural level and not just as a string. Now, what does this mean for you today? For local deployment, the VS Code extension with Fusion is a great experience, right? You can try it out today. You can spot SQL errors in your editor, you can get autocomplete, and also trace column lineages easily. For deployments, Fusion's ahead of time compilation or rendering means you stop burning warehouse compute before discovering errors mid-run. So you don't have to run all your models to find out that one model is bad or has a syntax error. If there's a syntax error downstream, you can detect that problem even before executing against the warehouse. As I said earlier on, at the time of this recording, Fusion is available on Snowflake, and also I think beta on DocDB, and coming soon on some other adapters. On the screen right now, you can see a full supported feature matrix that shows what's available in Fusion across the Fusion platforms, that's CLI, the VS Code extension, and also DBT data platform as well. For platform features like state-aware orchestration, you need a paid DBT platform plan. And this feature essentially helps you to track which models actually need to be built, or which models actually needs to be rebuilt based on real data and code changes, not everything in the DAG. So Fusion doesn't try to run everything in your DAG, it tries to only run things that have changed, right? So it just essentially state-aware orchestration, if that makes sense. Okay, so if you stayed up to this time, thank you so much. So for a quick recap, here are 3 things to take away from this video. First of all is that DBT Fusion is a completely new piece of software built in Rust. It's not an update or upgrade of DBT Core, it's a replacement engine designed to eventually take over and supersede all from DBT Core. Secondly, is that one fundamental difference or one fundamental value of DBT Core is static analysis. Fusion renders and validates your entire DAG and can catch SQL errors, lineage issues before execution. And thirdly is that Fusion is available today for free via the Fusion CLI, via the VS Code extension, and also DBT Cloud platform. Alright, so that's it today for episode 1. If you found this useful, I'd like you to subscribe to the channel, as I'll be covering the entire Fusion engine in this series, episode by episode, and I don't want you to miss any of it. Feel free to also connect with me on LinkedIn as well, and maybe you have some thoughts, questions, I'd like you to drop them in the comment section. I'll be excited to hear from you, to just, if there's perhaps anything you want us to dig more into within the Fusion engine, I'll also share them. And next couple of videos we'll have some demos as well. But for this one today, this is just an overview of what Fusion is all about. So I'll see you in the next one. Bye for now.